All right, here we go. Finishing up 2.4. Make sure it's 2.4. Yep, 2.4. Okay, so next we're going to be solving the following quadratic equations using non-calculator. Find the zeros. So factoring, completing the square, and quadratic formula. So it looks like this one's set up that we can factor it. Could we factor that? Looks like a difference of squares. So there's actually two ways to do number 13. I mean, you could do all three ways actually. So this can be factored into 3 times 3, and x squared factors into x times x, and 4 factors into 2 and 2. Wayo! And so that would be plus and a minus because there's no middle term. So it's a perfect difference. It's a difference of squares, factoring. And so then we just set each of those equal to 0. So we get 3x plus 2 equal to 0, and 3x minus 2 equal to 0. And we minus 2 to both sides, so we get 3x equals negative 2. And then we add 2 to both sides on this one, and we get 3x is equal to positive 2. And then divide by 3, divide by 3. Right? So we get negative 2/3. We get negative 2/3 and positive 2/3. Wayo. Another way we could have done that is we could have 9x squared minus 4 equals 0. Add 4 to the other side. 9x squared equals 4. Divide by 9, divide by 9. And then square root both sides. And when you square root both sides, you get plus or minus the square root of 4/9. And that, of course, reduces to, the square root of 4 is 2, and the square root of 9 is 3. So plus or minus 2/3, same answer. So yeah, you can do factoring or kind of completing the square final thing where you get everything to the other side and square root both sides. 15 looks like a factoring one. So we're going to get everything on the same side first. Get everything on the same side first. So we're going to minus 14 to the other side, minus 14. And then we're going to go into factor, see if it factors. If it doesn't factor, you have to do the quadratic probably, or complete the square. So x and x, factors of 14 are 2 and 7. So, pause me, try this on your own, remember? Pause me. Side middle term goes with the bigger number. So negative 7 and positive 2. So negative 7x and positive 2x. When you add those together, you get negative 5x. Wayo! So now we set each of these equal to 0. So x minus 7 equals 0. Add 7 to the other side. And set x plus 2 equal to 0. Minus 2 to the other side. So we get 2 x-intercepts there. Number 17, that looks like a toughie. So we're going to minus 4 first, so we get 98. Then, is there a GCF? What do you think? What do we do here? I'd like to factor it. Yeah, there's a 2. Is there a 2 we could pull out? So we pull out the 2. We get x squared plus 14x plus 49. Well, that's going to factor to x, and factors of 49 are 7 and 7, plus a plus, wayo. Now that 2 is going to go away when you set them equal to 0, because you're going to divide it all by 2, divide it all by 2. 2 is still a factor, but we're trying to solve for x. So divide to the other side, that goes away, and then we just set both of them equal to 0. Set both of them equal to 0. And so it's a multiplicity of 2. We get negative 7. You can say both times, I guess, or just once, because it's a multiplicity of 2. And then we jump to number 19. So number 19 could be quadratic. It's looking suspicious there. So let's just jump to that, because that just seems easier for this problem. So your A is 8. Your B is negative 6. And your C is a positive 1. C is a positive 1. Good. Not a negative 1 because you have to add it over to the other side first. And then we go x equals negative b negative 6 plus or minus the square root of b squared, which is negative 6 all squared, which is 36. Pause me. Try a quadratic formula on your own. Pause me. Plus a negative 4 AC, where your A is 8 and your C is a 1, all divided by 2A, where A is actually 8. Whoa! So then we get x equals negative b, which is a positive 6, plus or minus the square root of 36. Careful now. So plus a negative number, so negative 4 times a times 1 is a negative 32. Ooh, all over 2 times 8 is 16. And then that equals 6 plus or minus, oh, what's 36 with the negative 2? The negative 32. That's a beautiful 4. Whoa. So we get the square root of 4 when you combine 36 minus 32, you get 4. And that's really pretty because that's just 2. So we have 6 plus 2 over 16. Because the square root of 4, remember, is 2. And so then you also have a 6 minus. You also have a 6 minus 2 over 16. Those are our two answers there. So that's going to be 8 over 16, which equals a half. And then 6 minus 2 is 4 over 16, which reduces to 1/4. Whoa! So those are our two answers. X equals a half and 1/4. Don't forget to plug your even answers into Canvas. That was a good one, right? With the quadratic formula. Maybe you could have done it a different way. Maybe complete the square. And then that's, let's see, 21. So we're going to add 3 to this side, so we get negative 8. Let's see, do we think that's factorable? Should we just jump right to the quadratic? Yeah, I wouldn't use complete the square on that one. So I would probably use quadratic because that just looks scary. I don't see that working out. 2 and 4, let's see, 2 times 5 is 10. And then 10 with the 4, that's not going to make 8. Yeah, I don't know. I'll just do the quadratic. So A equals 5, B equals negative 8, and C equals negative 8. X equals negative 8 plus or minus the square root of B squared minus, no, add a negative 4 AC. That's so you don't mix up your negatives at the end, right? I do a plus and a minus because you're basically adding something negative. So our A is 5 and our C is also negative 8 all over 2A. 2 times 5, just 10. So we get x equals negative is a positive 8 plus or minus, that's 64. Negative 8 squared is 64. Let's see. So 5 times 8 is a negative 40 times a negative 4 is 0, and then a positive 160. Whoa! And then 160 plus the 64 there is going to be 421. So that's going to be 224. Wow! Square root of 224. And that's all over 2A, which is 10. And then your 224 could probably break down more, right? So we try some perfect squares there with our calculator. So 224 divided by 36 maybe? No. 224 divided by 16, that's a perfect square. Whoa! So we break that and down into 16 times 14, right? We use our calculator. I just used like 9, 16, 25, 36, 49 perfect squares to see. And it worked. And so that means that 224 then, with the square roots, that square root of 16 now is going to become a 4. And so now we have 8 plus or minus, and then the square root of 16 is 4, so that comes out. The square root of 14 is still there. And why does that matter? Why do we have to do that? Why do we have to do that? Because if you can reduce it, you need to. And they're all divisible by what? 4? No, 10's not divisible by 4. They're all divisible by 2. Way-o. So then you get 8 divided by 2 is 4, plus or minus 2 radical 14, because 4 divided by 2, all over 5. There's our answer. So x equals, there you go, so x equals 4 plus 2 radical 14 over 5, and 4 minus 2 radical 14 over 5. Wow, that was a tough one. Quadratic formula, get practicing. Last but not least, number 22. I chose a random number, like 100, just to see, and that could be a way to do this. There's other ways to do it mathematically, I'm sure, but watch this. If I take a number, I don't know, choose maybe 100. That's a nice, easy number to do percentages with, right? And so I go 100, and I increase it by 25%. So what is 25% of 100, right? It's 25. Plug that in your calculator, 25. So now we do 100 plus 25 is 125. And the resulting number is then decreased by 20%. So we're going to minus 20% off of it. But now we got to go to multiply by 20%. And when you do that, what's interesting, when you do that, you actually get 25, right? Let's try it. So 125 times 20%. Yeah, it's 25. And so you take your 125 and you minus 25 and you're back to 100. Way-o. So you just get your number back again. You just get 100% of your number back again. Not that that 100 mattered, but just getting your number back again is 100% of your number. Thanks for watching. Stay tuned for 2.5. Keep trying your best. You got this. Don't give up. Keep trying. You got this. Peace out and bye for now.